Right, we're looking now at drawing an atom. This is, in some senses, probably the most important lesson, the most important thing in science that you can learn. Because if you don't learn this stuff, then so much more other stuff won't make sense. When I talk about ionic bonding or covalent bonding or relative formula mass or any of that, or most of chemistry, if you don't understand this stuff, you are going to struggle. So it really is very, very important. I would say if you're only ever going to look at one of my videos, make it this one. And we're going to start by looking at atoms. So what is an atom? The word atom, atom, means that you cannot split, indivisible. So it's the smallest building block of matter. You can't divide it up anymore. It's the smallest part of matter that there is. If you could chop stuff up to the smallest powder possible, the smallest atomic powder, what you'd have would be a big pile of atoms. And by matter I mean solids, liquids and gases. So everything in the universe, from a star to your house, is made of atoms, including yourself. Now, an analogy that I like to use in class is that atoms are a bit like Lego bricks. You can't break an individual Lego brick apart, not without hacksawing it. But you can't. It's an indivisible unit. But what you can do with Lego bricks is you can stick them together and build models out of them, build larger models out of them, and then you can take those models apart and you can build a different model out of them. And that's exactly what atoms do. Atoms stick to other atoms, and large models are made from them, and then those models can be taken apart and built into new molecules. So in that sense, they are very similar. It's a good analogy. So I'm telling you that everything in the universe is made of atoms. So let's have a look at this. This is the periodic table. This is all of the different kinds of atom there are. Okay. Now they differ mainly in size. So for example, the smallest one up in the top left hand corner there is hydrogen, and you can see the little 1 there, so that's the smallest. And then you go all the way across to the other side, you've got helium, He, and that's 2. And they get heavier and heavier and heavier as you go down the periodic table. So in my analogy, the periodic table is basically kind of the Lego set for how to build everything in the known universe. So for example, you are mostly water, which is H2O, so you're mostly hydrogen and oxygen atoms, stuck together in that way. Quite a lot of carbon in you as well. Stick these models together, and with those 3 atoms you can build most of your body. So this is what it is. The periodic table you can think of as the Lego set for building anything in the known universe. Right, let's talk about how to draw one of these things. This really is important that you can do this. So we've got lithium here. We've got the Li, and that stands for lithium. Now some atoms don't make so much sense. I mean, there are ones like O for oxygen and C for carbon and N for nitrogen, and they make sense. There are some like sodium. You'd think sodium would be SO, but it's not. It's Na. And the reason for that is because some of them come from Latin and some come from Greek and some come from other places as well. But most of them make sense. So the letters tell you what the name of the element is, so Li is for lithium. And then you've got this small number. Now sometimes the small number is down the bottom and sometimes the small number is at the top. It depends whether you're looking at an American or an English periodic table. Doesn't matter. The smaller number is the proton number. It's the number of protons in the nucleus. So the nucleus is the middle bit of the atom, the central part. It's called the proton number or the atomic number. So there are 3 protons in the middle bit, in the nucleus of a lithium atom. Now that is also the electron number. Okay, so we know, what do we know so far? We know that we're talking about lithium, we know there are 3 protons, and we know there are 3 electrons. I'll go into a little bit more detail about what protons and electrons are in a second. You don't find electrons in the nucleus, they whiz around the outside, but you'll see that in a sec. Right, we've got this other number down here, 6.941. Don't worry about all those decimal places. It rounds up to 7, and we'll go into why there are decimal places in another video. This is called your relative atomic mass. It's the complete mass of the nucleus. It's how much does the total nucleus weigh. Now, hang on, what have I just told you? There are 3 protons in the nucleus, and now I'm telling you the whole nucleus weighs 7. So you should be able to realise that there must be something other than protons in that nucleus, and there are neutrons. So let's draw one of these things then. There are 3 protons. Now the entire nucleus weighs 7, and if 3 of those 7 are protons, how many neutrons must there be? Okay, there are 7 in total. 3 of those 7 are protons, so there must be 4 neutrons. 3 plus 4 equals 7. That's it, that's the nucleus done. We're most of the way through. Now that we've got to put the electrons in. I told you the electrons whiz around the outside in things we call orbits. Now there are some rules here. I've just told you that the proton number is the same as the electron number, so I know there are 3 electrons. Now the first shell, we call them shells, can only hold 2 electrons. You could never put more than 2 electrons in the first shell, and you have to fill that one up first before you jump onto the next one. So the first one holds 2. Now we need 3, so that means we're going to have to jump onto the second shell and put 1 there. So there we are. That's it. We've got 2 electrons in the first shell, 1 in the second shell, and that makes 3. Protons 3, neutrons 4, electrons 3, and that is a completed atom. That is how you draw an atom, and that's what this video is all about. If needs be, the first shell can hold 2, the second shell can hold 8, and the third shell can hold 8 as well. And we will never ask you to draw anything bigger than that, so just bear that in mind. I said we'd look at protons, neutrons and electrons in a little bit more detail. Let's start by looking at relative charge. Protons have a +1 charge, pro, plus, so they've got a positive charge. Neutrons don't have any charge at all, neutrons neutral. So those are the only 2 things in the nucleus of an atom. So the overall charge of a nucleus is plus, depending on how many protons it's got in it. The hydrogen has a +1 charge. The nucleus of a lithium atom that we just looked at has got a +3 charge. Electrons have a negative charge. Now, in lithium, which we just looked at, 3 pluses, it's got 3 protons in the middle, it's got 3 electrons, 3 negatives going around the outside, and those 3 pluses will cancel out those 3 negatives, and the whole atom will have no charge at all. It will have a 0 charge. And that's the case in all atoms. Every atom on that periodic table that I just showed you has no charge, because they've all got the same number of protons as they do electrons. If they didn't, they wouldn't be atoms. Okay, so bear that in mind. All atoms are neutrally charged. Let's have a look at relative mass. Protons have a mass of 1, neutrons have a mass of 1, and electrons have a mass of 5.45 times 10 to the minus 4. Now that's a very, very small number. In future, we will say electrons have no mass. They have a minuscule mass, but we're going to say no mass at all. Let's go through another example, because you're going to need to be able to do this. So we've got nitrogen this time. We've got 7 at the top and 14 down the bottom. The small number is 7, and now that is, if you remember, that is our proton number. So we've got 7 protons in a nitrogen atom. Now, do you remember what that bottom number means, the larger one of the 2? What some people do, mistakenly, is they see that and they think nitrogen has got 7 protons and 14 neutrons. No, that's not the case. The entire nucleus of a nitrogen atom weighs 14. 7 of those 14 are protons, so how many neutrons must there be? Well, there must be 7. So that's the nucleus done. What about electrons? Do you remember what I said before? There are the same number of protons as there are electrons, so there are 7 protons and there must be 7 electrons. Do you remember how many go in the first shell? 2. You can only fit 2 in the first shell, so how many more do I need? I need 7 in total. I've got my 2 in my first shell, so I need another 5. And that is an atom of nitrogen. Okay. They sometimes represent the electrons by this electron configuration, 2, 5. That just means there's 2 in the first shell and 5 in the second shell. So there you go. I've completed another diagram of a nitrogen atom this time. If you can't remember how to do it, just scroll back and listen to it again. But what I'm going to ask you to do now is have a go at these questions. Try them out. I've given you all the numbers and letters that you need down there. Pause the video now. Try it out and then unpause it and have a look at the answers. Thanks for listening.